Welcome to our channel Biswanka's Math Exclusive. This video is on Laplace transform. So what is the definition of Laplace transform? The definition is the Laplace transform of a function ft of real variable t defined for t greater than equals to 0 is denoted by Laplace of ft equals to integration 0 to infinity e to the power minus pt ft dt equals to fv. This is very important formula. Remember it. Provided the integral exists. Which integral? This integral. Provided the integral exists. Here p is complex and consequently the Laplace transform of ft is a function of complex variable p. Now come to the property of class function. A class function ft for which their Laplace transform exists, that is the integral integration 0 to infinity e to the power minus pt ft dt exist and satisfy the following property. Number 1 property, ft is piecewise continuous in any finite interval of t for t greater than 0. Now let if ft is continuous in the interval 0 to the piecewise continuous, that is 0 to half and half to 1 is also continuous. Number 2, ft is of exponential order at t tends to infinity, that is mod of ft less than equals to capital M e to the power at for t greater than 0 and for some real positive constant a and m where a is called the index of order of growth of the function. Now come to a theory. If a real valued function ft of real variable t is piecewise continuous in any finite interval of t and is of exponential order o e to the power at t tends to infinity when t greater than equals to 0, then prove that number 1, the integral 0 to infinity e to the power minus pt ft dt converges in the domain real p greater than a, and number 2 is ft, the Laplace transform of small ft is analytic in the domain real p greater than a for complex p plane. Now start proved. Number 1, since ft is of exponential order, that is order e to the power at t tends to infinity, then there exist two real positive constant m and a such that mod of ft less than equals to capital M e to the power at. Therefore, mod of integration 0 to infinity e to the power minus pt ft dt less than equals to here is the mod of total, here I break the mod, so the sign is less than equals to integration 0 to infinity mod of e to the power minus pt and mod of ft dt less than equals to integration 0 to infinity mod of e to the power minus x plus I by t into m e to the power at dt where p equals to x plus iy complex function less than equals to m capital M into integration 0 to infinity e to the power at into e to the power minus xt mod of e to the power minus iy where e to the power minus iy equals to 1. So less than equals to capital M limit capital X tends to infinity, integration 0 to capital X e to the power minus x minus at dt, where x is a finite quantity, less than equals to capital M limit x tends to infinity e to the power minus x minus t x minus a into t by a minus x in the limit 0 to capital X, less than equals to 1 by x minus a minus limit x tends to infinity e to the power minus x minus a into x tends to m by x minus a. Here also m less than m by x minus a. If x minus a greater than 0 implies x greater than a implies real p greater than a. So, mod of integration 0 to infinity e to the power minus pt ft dt tends to m by x minus a, finite provided real p greater than a. This shows that the integration 0 to infinity e to the power minus pt ft dt be absolutely convergent in the domain real p greater than a. Hence the integral exists. Proved. Number 2. We divided the interval 0 to infinity of t into intervals t0 to t1, t1 to t2, tn minus 1 to tn of finite length, where t0 equals to 0 and tn tends to infinity. And we consider a sequence of functions u and p, where u and p equals to integration tn minus 1 to tn e to the power minus pt ft dt and n equals to 1 to . Now mod of capital Fp minus summation of k equals to 1 to n ukp equals to mod of integration tn to infinity e to the power minus pt ft dt, less than equals to integration tn to infinity mod of e to the power minus pt into mod of ft dt, less than equals to capital M into integration tn infinity e to the power minus x minus at dt, numbering it equation 1. Now let x minus a greater than equals to delta, where delta greater than 0 be arbitrary. Then e to the power minus x minus at less than equals to e to the power minus delta t. Therefore, from 1 we have mod of fp minus summation of k equals to 1 to n un p less than equals to capital M into integration tn to infinity e to the power minus delta t dt, less than equals to capital M into e to the power minus delta tn by delta tends to 0, as n tends to infinity implies tn tends to infinity. For any epsilon greater than 0, there exists a positive integer n such that m by delta e to the power minus delta tn less than epsilon for all n greater than equals to capital N. Thus, for any epsilon greater than 0, there exists a positive integer capital N epsilon such that mod of capital Fp minus summation k equals to 1 to n ukp less than epsilon for all n greater than equals to capital N, and for real p greater than equals to a plus delta. This shows that summation k equals to 1 to infinity ukp converges uniformly to capital Fp in the domain real p greater than equals to a plus delta, that is the domain real p greater than a, as delta greater than 0, arbitrary, and its sum capital Fp is analytic in the same domain real p greater than a. This is the theorem. Proved. Today my topic is end. If you find my video is helpful for you, please like, share and comment. And find this type of video notification, please subscribe our channel. Thank you.